3, 4 system of equations and 3 variables. We're going to solve in a system that has 3 variables. We're going to do it 3 variables, x, y, z. You all know the xy graphs, 2D, and x and y. That's a 3D graph. It looks a little funky there, but the way this works is this is x, this is y, this is z. And really, let me ignore this. Let's fill this out real quick. The general idea is x, y, z, the positive values. And if you fill it out, it'll be the corner of a room. See it better there. That's an XYZ. They're planes. Here's the ZY plane. Here's an XY plane. Here's the XZ. What happens with planes, same thing happens with lines. They all cross at one point right there in the middle. Then you have one solution, independent. Or they could all cross at infinitely many points. All these straight planes are crossing the whole line there. Infinitely many solutions. Or dependent. They could be this exact same plane, infinitely many solutions. Or it could be no solutions. This happens different ways. You could have, in this case, x and y cross, y, z cross, but they don't all cross at one point. So that's why there's no solution for all of them. Same thing here. Oh, these two cross, but they don't all cross. There's not one solution for all of them. Or maybe none of them cross. In this case, inconsistent. Now that we know that it's like a 2D system, a 3D system also has one solution, filling my solution, no solution, let's go about solving. This is a system with 3 equations, x, y, and z. You actually go about solving in lots of different ways. You could do substitution if you want, which in this case, personally, I don't think it's the best way. But I'm going to focus on elimination. I think that's the general best way to do this. Here's the rule number 1 about doing this. When you do elimination, you got to eliminate the same variable twice. A lot of times people go, okay, I'm going to get rid of the x's here. And then you get to the next one. Ooh, it's actually a lot easier to get rid of the z's than this too. So they get rid of the x's and they'll get rid of the z's. Not the best idea. Get rid of the same variable twice. That's where eliminate the same variable twice. And then once we do that, we're going to solve the 2 new equations. It'll make more sense in a second. Solve the 2 new equations like normal. And then once you solve those, you go back, substitutions in to any original equation to find the last one, to find the last variable. The idea is eliminate the same variables twice. If you do that, you can be fine. Let me name these. I like to name A, B, and C. We got to decide which variable we want to get rid of. Canceling stuff out, z would probably be the easiest because it's by itself. So I can multiply it by 2 to get rid of this z. I can multiply by 5 to get rid of that z. But I don't know if it's going to make the rest of it easy. But let's get rid of the z. So I'm going to do A and C first. If I want these to cancel out, I'm going to multiply the bottom row by -5. Multiply the whole bottom row by -5. First, I'm going to leave it alone. Now, it's easy to make a small mistake, just forgetting a negative or adding a negative where it shouldn't go, and then you messed up for the rest of the problem. Multiply the bottom row by -5. -5 times 5 is 25. -5 times 3 is -5. -5 times z is plus 5z. I do a negative because I want them to cancel out. I don't like subtracting. And then -5 times 17 is a positive 50 plus 35, 5. Hopefully I did it right. You add them up. These cancel. You get 27 minus 11y equals, let's see, 3, down, 103. That's my first new equation. Box it, that's my new equation. 27x minus 11y equals 1. The key to this is get rid of the same variable twice. I got rid of the z's, I gotta do it again. I'm gonna pick C because that's easy. I can't do what they already did that, so I'm gonna do C and B. The reason I'm doing C is because it has a z by itself. I'll multiply the bottom row by 2, and that should get rid of the z's. I'm gonna keep B alone, B the way it is. And then I'm multiply my C row by 2. Negative 10x, 6y, minus 2z, and negative 34. And we're going to add, I get negative 13x, plus 11y, those cancel, and I get 1, negative 61. Once you get your 2 new equations, go step 2. Solve the 2 new equations like normal. I'm just going to rewrite these. We have them right on top of each other. 27x minus 11y equals 103. Negative 13x plus 11y goes negative 61. I have this. All we're going to do here is solve like normal. I got lucky in this case because my y's cancel out when I add, and I just get 14x equals 42. And then I could solve that, divide by 14. I get x equals 3. I'm not done. Remember, solve like normal. I have my x, plug it back into one of these to find your y. I'll plug into the bottom one. I got from my y. Negative 13 times 3, plugging my x in, plus 11y equals negative 61. Negative 39 plus 11y equals negative 61, plus 39. 11y equals 39. Oof, that is 22. There we go. Divided by 11, negative 22 actually. Y equals negative 2. I have x, I have y, and y is negative 2. The last thing I gotta do is sub those solutions into any original equation to find the last variable. I go back here, you plug it into any one you want that has a z, and then you can find the last one. I'm gonna plug it into the top one, 2x plus 4y minus 5z equals positive 18, I think. Double check. Yeah. And then all we gotta do here is solve it normal. Sub in the 3, sub in the negative 2. I get 6 plus negative 8 minus 5z equals 18. These are on the same side, so I just add negative 2 minus 5z equals 18. Add the 2. Negative 5z equals 20. Divide by 5. Z equals negative 4. My x is my y. That's how you solve it. And remember, your answer is a coordinate point. So let's do a couple more to make sure we got this. It's always the same idea. Eliminate the same variable twice. Once you do that, you just solve your two new equations like you normally would. Once you solve those two, go back, plug in your two solutions to any one of the original ones to find a missing one. Let's do this next one. And this next one has a little bit of a twist. If you notice, this one right here is already missing a variable. What happens in that case? Well, you can treat it like normal. What I do is I move this onto the finals. I make this one my new equations. It already got a first round bye. What I got to keep in mind though, this is missing b. I'm gonna use that to my advantage. So in these two, I'm gonna eliminate b, so they match. This is missing b. I'm gonna eliminate b here. I don't know how to do this. I could do it normal. I could just get rid of a's here, get rid of the a's there, and just treat it like a normal problem. But we want to use that to your advantage. Is this missing b? So you gotta get rid of b in these two. These are my equations. If I want to get rid of the b's here, I want to multiply the top by 3 and the bottom by 4. Okay, 3 times my top equation, negative 9a minus 12b plus c equals 3 times that is 84. And then we're going to multiply the second row here by 4. The b's could cancel out. 4a plus 12b minus 16c equals 4 times that. It's negative 124. Then add them up. These cancel. I get negative 5a, negative 10c equals negative 4. Look at that. Not bad. Before I combine these, it's my new equation. If you notice, these are all divisible by negative 5. If you want, you make your life a little easier and divide all this by negative 5. You're going to get 8 plus 2c equals 8. Here's one equation, and here's another equation. Let's solve those two like we know. Let's do it right. 2a plus 3c equals 8. And a plus 2c equals 8. Let's multiply the bottom row by negative 2. Negative 2a minus 4c equals negative 16. A's would cancel. Negative c equals negative 5. Also just c equals 5. Once you get 1, don't forget to go back, sub it in, find the other one. You can plug it into any one of the two new equations. So that one or that one, doesn't matter. I'll use that one because it's right there. A plus 2 times 5 equals 8. A plus 10 equals 8. A equals negative 2. I have 2 of them. All I gotta do is go back, plug it into any one of the original ones to find my b. Well, I can't plug into that one because it doesn't have a b, but I'll use the middle one. A plus 3b minus 4c. So I'm gonna plug it back into this equation. A plus 3b minus 4c equals 31. Right, but both of those into here, sub them in. I get negative 2 plus 3b minus 4 times 5 equals negative 31. This is negative 20. I can add those up. I get 3b minus 22 equals negative 31 plus 22. Your book generally has all these work out nicely. So if you got a bad answer, you probably made a small mistake somewhere. So you didn't make a small mistake. B equals negative 3. Those are my answers. A is negative 2, B is negative 3, and C is 5. And that's the general idea. Eliminate the same variable twice. In this case, I just use it to my advantage. Once you get your two new equations, just solve them like you normally would. And once you solve those two, just go back, plug it into any one of the originals. Okay, one more problem. This one's a little different. We're going to start the same way. This is A. I got to pick a variable to get rid of. I think Z, because notice how Z is alone right there. So I'm going to eliminate Z. There we go. Let's do A and B together. If I want these to cancel, I'm going to multiply my top row by 5. 5 times 3 is 15. 5 times 5 is 25. Negative 5Z equals 60. Multiply the whole row, even the 12, so that's 60. I'm going to keep the second row the way it is. Negative 2x minus 3y plus 5z equals 14. I'm going to add them up. This is 13x plus 22y gone equals 74. I have that. That's the first two. I'm going to do a because that's a z I want, and I'm going to do a and c. I already did a and b. If I want these to cancel, I'm going to multiply a by 3. 3 times 3 is 9x plus 15y minus 3z equals 36. Keep c the way it is. I get 13x plus 22y, these cancel, equals 74. And if you look at it, they're the exact same thing. My two new equations are exactly the same. I'm going to have 13x plus 22y equals 74. 13x plus 22y equals 74. Happens here, let's subtract them or whatever. You're going to get 0 equals 0. That is a true statement. When it's a true statement, you get infinitely many solutions. If it was a false statement, it would be no solution. In this case, it's a dependent system, infinitely many solutions. And that's the lesson.